Je vais avoir le plaisir de donner la parole à John Christy. John Christy.
Let me now give over to John Christy, who joins us from Huntsville, Alabama, where he works in a university. And realists may not know John Christy or his university, but they do know the UAH curve, and those are the initials of the entity that he works with. And he's going to tell us about the history of Earth's temperature.
Thank you very much for having me here. We will see if I do not know French, but these computers seem to know each other's language, no matter where they are. And I am amazed when that happens. All right. I want to thank Benoit and Marie-France and Pierre, who gathered me together to get here this evening. I had an interesting journey getting here, but I am here, and I'm just delighted to be amongst people. Many of you look about my age. We have grandchildren and so on, but I suppose you are here because you have the experience of life that brings you to the point of being skeptical about people who make exaggerated claims. I'm going to put some of those claims to test tonight, claims that you've heard, claims that the most prestigious scientific academies believe. But when you put those to the test, you'll see they don't quite make sense. So when we're talking about climate change, what we're talking about is the influence of extra greenhouse gases that we put into the air to create energy. And in terms of scale, we want to know what is the impact on the climate of an extra 0.5 unit out of a system that exchanges units on the order of 100 or more. What does that extra 0.5 unit actually do? This is the most complicated slide I have tonight. The sunlight is the number of units of energy coming in, that's yellow. Part of it goes to the atmosphere, which is the blue box. About 2/3 of it comes into the surface, which is the green line. So we have units of energy coming in from the sun, and you can see how those units of energy move from one place to another. And in the atmosphere, what does an extra 0.5 unit do when you're talking about tens and hundreds of units already? In fact, those values vary by more than 1 unit all the time. So extracting that tiny 0.5 unit is a very difficult job to try to understand. Now, let's look at it as a tug of war. So this is the surface temperature. Those guys on the left are cooling the surface, making it cooler. Those on the right are making it warmer, and sometimes the guys on the right win, and so it gets hotter. More energy is coming in than leaves, and other times vice versa. Here is to scale what the extra CO2 and greenhouse gases are doing. That's adding a very tiny, tiny little person helping to tug on the temperature. That's why it's so hard to find what the result of this extra bit is. So the problem should be made simpler by looking at the troposphere, where the atmospheric heat content is. If you remember the complicated slide I showed, if you're in outer space and looking back at the Earth, most of the energy comes back at you from the atmosphere, not the surface, but from the troposphere. So that's the layer of the air that you should look for to see if you can find some kind of changes. That's where the joules of energy are leaving the planet to go to outer space. In 1994, so that's 25 years ago, Dick McNider and I wanted to test the climate model trends. And at that time in 1994, there were only a couple of climate models, but they were showing a trend of temperature of 0.35 degrees C per decade. And we only had 15 years of satellite data, but we thought that was the best kind of data to use. What could we do? Well, what we did was publish a paper in Nature, and that was back 25 years ago. Nature magazine used to publish real science. And we were able to take out the fluctuations of El Niños and volcanoes and determined that the global temperature there in the box, the curve that's left, has 0.09 degrees C per decade. We only had 15 years of data. This was 25 years ago. So remember that number, 0.09. So if that was the greenhouse effect, it was about 1/4 of what the climate models were saying it was. So the models were greatly exaggerating it. Well, in 2017, Dick and I redid the study. Now we had 2.5 times more data, 37.5 years, to see how well our work was 25 years ago. So the top time series is the temperature of the globe, the global atmosphere. It goes up and down all the time. That second line, the gray line, is the sea surface temperature effect. We might call it the El Nino effect. Take that out, you get the third line. In the third line, you see 2 big dips in temperature, and those were due to the volcanoes El Chichon and Mount Pinatubo. So we can extract those, determine their impact, and remove it, and at the bottom you end up with pretty much a straight line that's warming at 0.095 degrees C per decade. I want to know, back in the United States, I asked this question, how many climate scientists wrote a paper in 1994 and had it exactly verified, basically, in 25 years later? It doesn't happen in climate. The forecasts are always way, way off. But here, using data, we are able to show that that trend is only 0.095 degrees C per decade. Now that's important because it means in this paper, we went forward and calculated what the sensitivity is of the atmosphere to the extra greenhouse gases. It's called the tropospheric transient climate response. Now we do have a major assumption here. We're going to assume that the only forcing is the extra forcing of the carbon dioxide and so on, and no natural variations. Big assumption, major assumption, but that's what we do. And then we can calculate, and this is kind of a complicated diagram, but what that is the IPCC has determined what the forcing is from all these extra greenhouse gases. So we use the IPCC impact on the climate that they claim has happened in the past 25 years or so. And here we have the TTCR, which is the transient tropospheric climate response, which is a little formula there. And what we found is down here in the bottom, it says 1.1 degrees C for the time when carbon dioxide doubles in the atmosphere, about 70 years. In other words, if you increase the forcing 1% per year, in about 70 years you double. And so this says in 70 years, the temperature will be about 1.1 degree warmer than today. We applied the same analysis to climate models, came out with 2.3, or a little more than twice as much. So for the atmosphere, the best climate models were showing a little over twice the sensitivity of the actual climate to CO2. Now, so the evidence that we had from these papers shows that the sensitivity is just wrong in the climate models. And I make that point because it is those climate models are the basis for the regulations that you and I live with today. So because your energy is higher, it's due to the belief that this sensitivity, the Earth is very sensitive. Well, we wanted to know, was there another metric that we could use to, again, test climate models and see what that little guy, that 0.5 unit, was doing. And so Ross McKittrick and I published a paper last year in which we determined what that metric was. And that metric had to have these 4 qualifications. The response is seen in all the models and is a dominant characteristic, so there's no ambiguity. This response is not there when the model does not have extra greenhouse gases. So every time you have a control and an experiment, there is always a difference and it's always the same. And this climate must be an observed metric that is not used in developing the model. Surface temperatures are used in the development of the models. And so that should not be a metric you use to measure and see how well your model did. It's like me giving the answers to an examination on Monday, giving the examination on Friday, and being surprised that my students did so well. Well, that's because don't use surface temperature. That's what the modelers use to tune the model. Use something else. And finally, the observations should come from multiple and independent sources. You should not use the observations created by the people who made the model. There's a little bit of problem there. And so the metric we found was the atmospheric temperature in the tropics around 30 to 40,000 feet, 10 kilometers, 12 kilometers, something like that. The temperature in the tropics, around the tropics, that was a very clear metric in all of the models. In fact, here's an example. This is a cross-section of the atmosphere. The South Pole is on the left, the North Pole is on the right, equator in the middle, and it goes up. So the stratosphere is at the top. Since 1979, this is what models show the temperature trend to be. And it shows that big red spot there in the tropics in the area I just showed. So that is the place we need to measure the temperature to see the response. It's also very critical because that place in the atmosphere tells us about the water vapor feedback of the models. So it's an important place in the atmosphere to see how well the models do. So, and this has already happened. See, this is from 1979. In our paper, we went to 2017. So since this has already happened, we are going to be able to test it with real data. And what should be happening? The climate models say there should be significant warming there. So this is a hypothesis, a claim that we can put to the test. So this is 102 climate model trends. From 1979 to 2017, they average about 44 hundredths degrees C per decade, and 102 of them. I might say something about that in a minute. When you look at the actual observations, they're down here, 1/3 of what the models show. So here we have a case where the models are 3 times too warm about what's happening in the world already. Now, if an engineer built an airplane and said it could fly 600 miles or 1,000 kilometers, and it only made it 300 kilometers, he doesn't say, well, I was only off by a factor of 3. A factor of 3 is huge when it comes to scientific clarity, and especially if you're going to make people pay a lot more for their energy based upon such a false claim that we put to the test and we falsified. This is what the spaghetti diagram does, shows with the various models going very warm. There's one model that was pretty close to reality, that purple model there, and that is the Russian model. And in the United States, especially in the White House right now, you don't mention Russian things at all. And so it's good enough to see that big red line is the average of the models going very hot when the real world is not. Using a deeper layer, the satellite temperatures that we generate in Huntsville, Alabama. This is a big year, by the way, in Huntsville. Huntsville is the space center for building giant rockets, and 50 years ago this year, the Saturn V rocket sent men to walk on the moon, and that rocket was built right there in our city. Anyway, so using the satellite data, we get the same answer, and we have verified the actual observations from 3 completely different types of networks: satellites, balloons, and so on. The models fail. Now, in classical science, in the science I was taught, and I'm sure the science you were taught, when you make a claim, when you make a hypothesis, and it fails, you reject your hypothesis and go back to the beginning and start again. That's the way I learned how to do science. In science today, when someone shows that your hypothesis fails, you just yell louder that it's right. Yell and yell and yell and drown out the person who says, wait, your hypothesis fails. Okay, latest models. These are the CMIP-6, the ones that are just coming out right now. And I've got about 11 or 12 here to look at. I don't see any improvement. The model trends in the blue and the averages in the red is much higher, again, about 3 times higher than the 2 gray bars here, the observations. And if you look carefully, the second to the last category there, France. So I have 3 models from France that have now been published, and you see they are 2 to 4 times too warm. I don't know when sanity will come back to our science where someone will say, my goodness, my model is terrible, I need to do something else. Rather than, my model is great, just give me more money so that I can keep all my people employed and make more models for the future. We are investigating why this problem is. I see Dick Linzen down here. He's also looking into this. Why are the models not doing the real world properly? And so if you just look at that box on the end and think of the entire atmosphere, if it warms up 1 degree, what happens? So you're out in space looking down, and this column warms up by 1 degree. What do you see? And it turns out what you see is this. When you look in the model world, all you see is 1.4 watts per energy coming out when that column warms up 1 degree. When you look at the real world with our satellite data, we see 2.6 watts per meter squared. So you see what happens in the real world? When the air warms up, the heat escapes much more readily than in the models. The models tend to trap too much heat, and that goes on until the planet warms more than it actually is. This has been known for a long time. I was one of the authors of this National Academy report where we say a more definitive reconciliation of modeled and observed temperature changes awaits. Improvement of the models used to simulate atmospheric response to these natural and human-induced forces. That was 19 years ago. We await to see if we can solve this problem, but as you can see, the very latest models have not. And these will be the models you will hear much about in the next IPCC, and they will tell you the world is going to burn up because our models tell us it is. So the IPCC AR5 knew that there was a problem. This mismatch between models and observations most obvious in the tropics, but chose to avoid drawing attention to it. The IPCC chose not to draw attention to it. In my AR5 review, I pointed out this mismatch, indicating that the draft comments would never stand up in cross-examination. If the IPCC had to go to court and a lawyer on the other side cross-examined them, they could not pass. They would fail the test. Now, peer review is not a term to apply to the IPCC or its cousin, the U.S. National Climate Assessment. In these publications, the lead authors are chosen ahead of time, and they are given the final word. There's no chance their words will be rejected, as in a typical publication. So they write the reports, send them out for review. The comments come back like mine, and they say, we sent it out for review, but we will disregard those comments. We have the final say. And so that is why you get very biased results. It's only because the authors are pre-selected to give those terms. Okay? But I made such a big deal about this in the last IPCC that in the supplement they did include the truth. Though they didn't say anything about it, they didn't draw attention to it. What you see there is a chart from the supplementary material, and I'm going to blow it up in the next chart so you can see it. But there is the tropics right there, the blue observations basically, and the red model results. So let's blow that up, and this is what you see. The red is the trend in temperature. The trend is on the bottom, and the elevation is as you go up. The trend in temperature is in red from the climate models. If you look carefully at the white is what the observations show. There is no intersection between the two. the models are very much warmer, very much to the right of what the white is. Do you know what the blue is? The blue is the climate models without any extra greenhouse gases. Those models were verified by the data. In other words, it was better not to put anything in the models to get the right answer than to put greenhouse gases in and warm up the world way too much. But like I said, the IPCC did not draw attention to it. They did not explain it the way I just did to you. The only reason it was there in the supplementary material was because I made it very clear that what they said would not pass any test in court. This is a later publication in one of our publications that shows the trend in elevation, and you see the model trends are the red line with the error bars. The actual observed trends are the green line there going up. The box is that one layer of air I told you about that we looked at carefully between 30 and 40,000 feet. You can see that the models don't even intersect, even in their leftmost, in their coldest model, do not intersect with the observations. And that's published. So the rate of temperature increase in the tropical atmosphere, the rate of accumulation of joules of energy, is significantly less than that depicted in the CMIP-5 climate models. Will the IPCC AR6, the new one, investigate this long-running mismatch between the climate system models and the climate system of the real world? Will they become honest and investigate it and ask for it? Here's my prediction. I don't make predictions, but here is one. Past responses have been that the problem is one, oh, the observations must be bad, our models are right. Or two, well, the models didn't have the right forcing. But it's never three. Our models fail the hypothesis test. Though that is what the evidence shows, they will not say that. Now, you hear a lot about tornadoes and drought and floods and fires and hurricanes and so on. As scientists, you know, we measure things, so we count all of these. We monitor them over decades, so we know about them. If you go to tornadoes, the United States has more tornadoes than anyone. We actually had the fewest tornadoes of our history recorded just this past year. The trend is actually downward. Hurricane, I like this metric. It's hurricane days, tropical storm days, and major hurricane days. But it gives you the idea of how much time is being used by these hurricanes in processing that energy. And you see there's no trend at all in those. Here is one. We are told we are having record high temperatures all the time. This is a time series since 1895 of the number of daily records in the United States stations over time. It turns out, I don't see an upward trend. We are not having record high temperatures in our cities where our weather stations are. In fact, the top 15 years with the most record high temperatures of the top 16 occurred prior to 1955. Droughts, this is global drought since 1950. We don't see an increase in area or intensity. What about forest fires? This is North American forest fires, and what you see is a lot of forest fires before Europeans settled. Europeans do not like fire. They don't like fire to burn up their stuff. And so Europeans put out fires. If you think about it, prior to European settlement, nobody put out fires. And so fires would burn for months in North America. But now with the fact we put out fires, there are far, far fewer. And so when you look on the news and you see California is burning, the number of fires in California has declined. They won't tell you that. Now, I happen to own property in California in the fire zone. This is the foothills of California. I have not built a structure on my property because I can't figure out how to make it fireproof. This area is supposed to burn. Its natural condition is to burn every few years. And here is a cartoon that says, You want to buy a house? Come to the California foothills. Look how beautiful it is, when really you're putting a house in a forest of matchsticks. It will burn. That's what oak savanna forests do. Globally, the amount of area of forest fires and wildfires is declining, as you can see. We put out fires. What about snow extent? This is an unusual one because people think snow is going away. Yet when we measure it from satellite, measure the extent in the northern hemisphere each year, snow is not going away. We still have snow. In fact, the greatest snow cover was 6 years ago in the year 2012-13. Sea ice, geologists sometimes reverse the time, so today is on your left, and you can see that the current centuries have the most ice cover in the Arctic of the last 10,000 years. There was very little ice, in fact, 5, 6, 8,000 years ago in the Arctic. So the fact the Arctic has less ice than it did a few decades ago is nothing new to the Arctic. What about calamities? I heard a new term tonight, collapsology or something like that. We are getting smarter as people, and we are seeing fewer and fewer die. See on the right? That's the number of deaths due to weather and climate events. They're going to almost zero because we know 17,000 people in one of the countries, Bangladesh or something, were evacuated this week because we knew a storm was coming because of satellites. So people are being protected, far fewer are dying, despite what you hear on the news. What about grain? Are we producing more and more grain? You heard that we're going to run out of food. Well, every year is almost a record harvest around the world. Now, but everybody, Dr. Christy, says humans are causing dangerous global warming. Everybody says that. The United Nations, the US government, the National Academy of Sciences, the American Meteorological Society, New York Times, Washington Post, NPR, CNN, 97% of scientists, Leonardo DiCaprio, Al Gore, Alexandria Ocasio-Cortez, she is a new congresswoman in our Congress who is a very interesting character. And of course, university professors. Now, I want you to put your credibility scale on that. Who do you think is the smartest in that list? I don't know. But oops, their testable predictions have been falsified. We have just looked at the evidence to show that their predictions have been falsified. Yet, they get all the news coverage, obviously. These are called arguments from authority and arguments from consensus, but they are not arguments from science. People ask me, well, how can you go against the National Academy of Sciences of the United States, the most esteemed body we have? And I tell them, I did something none of those people on that panel did. I went to the archives of the computer models and I downloaded 102 model runs by myself on nights and weekends over several months. I processed each one of those climate model outputs to convert from their formatted data to satellite radiance and so on, so I can do a comparison with 102 climate model results. I have seen what is in those results, and I know more, therefore, than what the National Academy of Sciences does, because they did not do this. So science is the belief in the ignorance of experts, said Richard Feynman, physicist. And the great author and Dr. Michael Crichton, Jurassic Park, you know those stories. In science, consensus is irrelevant. What is relevant is reproducible results. What I showed you there, any of you can reproduce because it's just the results from the real data. Consensus is the business of politics. Now, as an aside, there is a strange thing happening in climate science, the proliferation of the unfalsifiable claim, i.e., the unfalsifiable hypothesis. Boy, that's a great one to have. Whatever happens is consistent with my global warming theory. Whatever happens. Heavy snow, lack of snow. More hurricanes, fewer hurricanes. This method says, wait for something to happen, then claim human-caused warming is the reason. That's the unfalsifiable hypothesis. But this has no testable information. It says whatever happens. There is no testable parameter. There's no predictive use. It is not science. The unfalsifiable hypothesis predicts nothing that we can use. Now, when we get to one of the reasons I'm very much involved in this is because I had lived in Africa, in upcountry from Nairobi, and I also live in a state in the United States where we have many, many poor people in the state of Alabama. I have watched what has happened to their bills because of these energy regulations. And as you can see in this chart, the proportion of energy costs to someone who is poor is much greater than to someone like me who's not poor. And it makes sense because we both have the same size gasoline tanks in our cars, and so we fill them with the same amount of fuel, but as a proportion of my income, mine's much smaller than someone who makes very little. So if you want to help the poor, quickest way is to lower energy costs. If you want to hurt the poor, the quickest way is to increase them. And that's what our government has figured out. They are hurting the poor the most. The Chinese lifted 400 million people out of poverty by building a coal-fired power plant every week. That was viewed as bad by the very wealthy environmentalist activist who said this. He said it as a terrible thing. But it was viewed as good by the 400 million people no longer living in poverty, and the many more millions who want to be in that situation. So morality is a question to consider here. Is it good or bad to enhance and extend human life? Are there extra emissions from carbon-based energy good or bad based upon what they have done to extend human life? Is it good or bad for the rest of the world to aspire to a higher standard of living, say about 1/3 that of an American? Is it okay to let them do that? Well, as you know, the amount of carbon being used in the world today keeps growing up, so the bottom three big wedges are carbon, then you have nuclear and hydro, and the little tiny wedges at the top are the so-called renewables. Our carbon dioxide emissions are increasing because, as I say up there, the evidence from actual data, the drive to live a longer and better life is preferable to succumbing to the constraints of environmental virtue. People want to live better, they want to live longer, and they are going to burn carbon to do it because today that is the least affordable path to affluence, to better health, and so on. And that's going to be the case for the future. As you see, countries have already said they're not going to really cut their carbon emissions like folks have said. Here's a question I had to answer for Congress and also in court is, well, what would happen if the United States followed a regulation limiting carbon use? So I said, I will make it easy. Let's completely eliminate the United States. No people, no cars, no industry, nothing. Just poof, the United States is gone. And you could see using a climate model, the effect is very small because we are not emitting that much anymore, and we're not sure about what the effect of carbon dioxide is on the climate. But anyway, that's the irony there, is the most draconian thing you can imagine. If we were to do that, it would have essentially no impact on the climate. The average American, and I think this is true for the average Frenchman, I think there is a lot of common sense in France. I don't see it in the newspapers or the news, but I think I see it among the people, that the average American and Frenchman is smarter than you think. They recognize it when an elitist is exaggerating a story, the end result of which is to deny this average guy some aspect of life he or she wants and needs, while the elitist maintains a luxurious lifestyle. The average American is rightly skeptical of environmental claims given the track record of doomsayers since the first Earth Day in 1970. I remember the first Earth Day in 1970. I was a college student, and craziest things were happening that day as these people thought they were saving the planet. But the Global Warming Policy Foundation took some of those forecasts from 49 years ago, the first Earth Day. Here's some of them. In yellow, population will outstrip any small increases in food supplies. I can't read the other one up there. But what have we had here? If you look at the result of the last 49 years at the bottom, it says food has increased from 2,300 calories per person to 2,800 calories as the population has increased. What about childbearing will be a crime? Down here in orange, China ended its one-child policy last year. And the other things too, life expectancy will go down to 40 years. Well, it's gone up by 30%. So many of these things that were predicted just did not happen. So here are the three conclusions of my talk. Theoretical climate modeling is deficient for describing past variations of climate. I've shown failed hypothesis tests, and thus highly questionable for giving an accurate information about how a relatively tiny forcing, that little guy, will affect the climate in the future. The weather we really care about isn't changing, and Mother Nature has many ways on her own of causing her own climate to experience considerable variations in cycles. And finally, carbon is the world's dominant source of energy today because it is affordable and directly leads to poverty eradication, as well as the lengthening and quality enhancement of human life. Because of these massive benefits, usage is rising around the world despite calls for its limitation. The IPCC has scolded us for 30 years, scolded the world, and yet you see carbon dioxide emissions just continuing on. So, thank you very much for the time here.
Merci beaucoup, John, pour cet exposé.
Thank you very much, John, for this really interesting presentation. Okay, I'm going to ask a question in English. I've noticed that you are listening to the translation. Recently, I read in a paper of a think tank IDRI that is associated with Sciences Po. I read that modeling of biodiversity were about to converge and produce magnificent results. What is your opinion on this?
I certainly haven't seen any magnificent results. That, by the way, is what you do when you're trying to write a grant to get money. That's what you promise.
John, is it true that the Environmental Protection Agency has labeled CO2 a pollutant?
Yes, the Environmental Protection Agency wrote an endangerment finding. It's called endangerment finding, that carbon dioxide is a danger to the world. That was written, of course, by people selected to write that very result. It was not a conclusion based upon science that was adversarial and cross-examined. It was based only on the conclusion of people who already had that belief. Yet now it is the law in the United States.
Yes, I was wondering one thing about, you seem to be concerned about the temperature in the tropics, but what about the Arctic or the Antarctic, etc.? I mean, that's one question. And the other is, I don't have the graph with me, but I've seen from the IPCC side, of course, graphs where you see an increase of temperature over the last, decades. I mean, is that completely made up, or did I dream, or I don't understand, because I've seen your spaghetti and so on with the average of the models, but there are also graphs that they show which show that the models actually fit the data, so I don't understand.
Okay, I concentrated on the tropics because that was the common signal in all the models. They have different signals in the Arctic and Antarctic. In terms of temperature in the Arctic has been warmer than it is today in the past. The 1930s were very warm, and go back 1,000 years, even warmer. Antarctica has not really warmed at all in the past 100 years, and going back, reconstructions of temperature show it to be a steady decline for the last 2,000 years, with a kind of a leveling in the last 30 or so. So Arctic temperatures go up and down very dramatically, and always have. I showed you the sea ice there. It's been much, much lower in the past than it is today. So The lack of sea ice is nothing new to the Arctic. Mother Nature can cause it.
The question is that I've seen graphs from the IPCC side showing that the temperature does increase and that it does correlate with their model. So are they cheating, or you never see those graphs? Or?
I think you're talking about surface temperatures. Models were tuned to match the surface temperatures ahead of time. So that's not a test. You want to test with an independent variable. That independent variable would be the tropospheric temperature. Plus, it's more sensible because it's the mass of the atmosphere where the greenhouse effect is supposed to be evident with the accumulation of joules of energy. So this is a much better test. I think that's about the answer.
Merci, monsieur.
Thank you very much for the numerous information, the body of information that you gave us in your presentation. Thank you. You have quoted your hearings in Congress. Is there, at a moment in the US Congress, a movement that may give us hope that rationality might win the day? Is the current American president playing a role in new thinking when it comes to climate change?
Will rationality invade the Congress? I doubt it. The president, I think, is more along this line. He has learned through his life of experience in becoming a billionaire that you really can't trust the claims of experts, that he wants to see the evidence himself. So I believe he is trying to create a situation where some of us can provide him that. But in Congress, I don't see that as a source of victory in this issue. I think the victory will come economically when people just start to complain too much about high energy costs.
Of Germany had said that their energy vendor, the change will cost more than $1 billion of euros, and that nobody can afford it. And he was a green. He was a very staunch green.
Yeah, Germany does have a problem. Their electricity costs are 3 times that of the United States. And in the world today, manufacturing uses a lot of electricity, no matter what you manufacture. So I think they're feeling the problem right now. Remember, China loves the fact we are making our electricity more expensive. That means we have to buy their stuff.
Hello, thank you very much for your talk. Do you think the temperature, the surface temperature records are biased?
Yes. I have actually published on that very thing. Not only are they biased, they are incomplete, and they are really not a very good metric to measure the greenhouse effect with. You need the bulk of the atmosphere. You're all very patient. I appreciate that.
Where are we now with the blue team and the red team, which was announced some months ago?
Okay, when I testified in Congress about 15 years ago, I recommended a red team. Not a red team, blue team, but a red team because the blue team already had all the money, all the publications, and everything. That the country just needed someone else to look at these conclusions with an independent eye. The climate establishment has fought that furiously. They do not want their results to be examined by independent scientists. There is a movement among the current administration to perhaps take a look at that, but I do not know the status of that possible examination. I just don't know.
Bonsoir. En France, on connaît des épisodes de canicule relativement...
In France, we've seen heat waves in the past 20 years, perhaps, and so I'd like to know how these heat waves fit into your theory.
heat waves happen. That's the nature of the climate system. It has many degrees of freedom and so can create these situations that you've seen. If we had 2,000 years of record, I suspect we could find some very serious heat waves in France. But we only have about 100 years or 150 years or so. Give it time, and we will, if we go back in time with good enough reconstructions, you will see tremendous heat waves in the past.
No microphone. John, the speaker is not using a microphone, and hence the interpreter cannot hear.
I see. The question was about heat waves and mixing up weather and climate forecasts. We will always have weather events. As one of my old climatologist friends said, weather records are made to be broken. That's just the nature of the system. Records will always be coming in the future for us because as the time series lengthen, that will happen. So be prepared. That'd be my main point, is be prepared.
Good evening. Martin Linzak has observed a cooling of the higher atmosphere. What can you tell us about that?
The stratosphere is cooling, and we see it in our microwave temperature data. Primary reason for that is the loss of ozone through about 1996. Since 1996, though, the stratospheric temperature is no longer cooling. If you go up very high to the very upper stratosphere, you still see a decline, probably related to more carbon dioxide. Carbon dioxide is a greenhouse gas. It is having an effect in places like the very high stratosphere. But we see less and less effect as it comes down to the surface. It just has too much competition with water vapor and aerosols and everything else.
I wanted to make a supportive comment rather than a question, and in French for one of the previous people who asked a question on extreme events. Je voulais juste dire à la personne qui a posé la question.
Just wanted to tell the person who asked a question about extreme weather events and heat waves in particular, and support you by saying that as John showed in his slides, and as many studies have shown, no increase of no extreme event that would be statistically significant has been demonstrated, and even the IPCC reports recognize that fact. There are none.
Bonsoir. Donc, comme votre prédécesseur Laurent.
Just like Laurent Alexandre, who spoke before you, said, supposing that climate warming is due to human-induced CO2 emissions, I think we should be blaming China and its development, as well as overnatality in Africa. Whereas what we're seeing is that most experts seem to be targeting Western populations. So don't you think that all of this expert discourse intends not to put the brakes on the third world's development, but actually to effect a transfer of wealth?
Oh, that's a very good point, is that the United States and Europe are no longer leaders in this carbon dioxide emissions. It is China, India, and so on. But I don't think you're going to tell them to stop because they want to have better lives and longer lives. That's a very big incentive to continue to create energy that's affordable. So that's going to happen. But you are right that our countries are the ones that get the blame and are told to do something about it. But as I said, if the United States completely disappeared, it's not going to have much of an effect at all. If France completely disappeared, you wouldn't even see the difference on that line.
John, you said the endangerment finding is law. Is it really law, or is it to be a law? And isn't it what William Happer is trying to debunk?
Right now, it is the law on the books, and the United States has to, with this law, demonstrate that it is reducing CO2 emissions. The current administration is doing everything it can to delay and to hold that law in abeyance which means to prevent it from becoming active, trying to find some way to withdraw it, have it withdrawn. It's very difficult to do because the Supreme Court gave the agency the authority to determine it, which is a terrible, terrible part of our legal system, because the agency is appointed by the administration, and the last administration wanted the endangerment finding. It was not a scientific process, it was a political process that got the endangerment finding. But the current administration is trying to have it withdrawn.
You're a member of the scientific committee in the EPA, aren't you?
I am a member of the Science Advisory Board of the EPA. The EPA was the agency that determined the endangerment finding. Will this committee, advisory board, investigate that? I don't know. I am one member of 44.
S'il va marcher? Ouais, Pascal Grindon, je suis journaliste. Il y a quelques années, on a signé avec...
A journalist's question. A few years ago, we pretentiously and pompously signed the Paris Agreement. Have you done a critical analysis of its contents? Since you're in Paris today, I wanted to ask the question.
Good question. We know from our own temperature data and how the temperature varies that we will not be able to detect the difference in global temperature with or without the Paris Agreement. It is that tiny. Remember, most of the countries don't have to do anything.
Ah oui, pardon. Oui, c'était à vous.
I'm sorry, it's called the Paris Agreement.
Bonsoir, monsieur.
Good evening. My name is François Martin. Thank you very much for your presentation. My impression was that the topic of your presentation was not so much the difference between models and metrics, but that another topic was also the inability of the elites to face reality and to prefer their dreams and their wishful thinking to favor it over reality. So I found that very telling. This is why I think that longer peace periods, such as the one that started in the 1960s, I could also mention multiculturalism or other ideologies. So I think that at times where the population is not living a period of peace, that these periods are marked by a return to reality. Do you think that actually there is a trend towards going back to reality? Do you think that we're going to be faced with the prospect of conflict, and that will allow us to see a leadership more able to face reality rather than a leadership that favors wishful thinking?
All right, that was a long question. Remember this, that scientists are people, and people like to be praised. People like to have high positions. They like to win awards. They like to get paid a lot of money. And by going along that path, people can be successful in that way, and scientists are people. Whether the average guy will be able to create enough disturbance to expose these elites for the false claims that they make, I think will happen someday. I think what we are doing is putting on the record that we are falsifying these claims so that in the future, when the economy is in terrible shape, a politician will be able to say, well, here is evidence that all this stuff is wrong, and we can then turn back to reality, like you say. I don't think it's going to happen tomorrow.
Bonsoir.
Good evening. I had a simple question, hopefully simple. What is your forecast for 2050 regarding climate change? So, or to rephrase, what do you think will be the determining factor that will contribute to climate change?
Okay, I told the group here earlier that I don't make forecasts. You know, that's a good way to ruin your name as a meteorologist, climatologist. If I were to guess, a hunch, in fact, I wrote a book, a chapter in a book about 2050, what we would be like. And I said there that we will be probably a little warmer than we are today, much richer than we are today. We will be safer than we are today. We will use, the world will be cleaner than it is today, because as wealth increases, all those things can happen. And I think the drive for wealth, happiness, in a free economy, free society, will win the day. I don't think my grandchildren, I have 5, and your grandchildren have to worry about the climate being a problem. Their biggest problem is what governments do to think they can deal with the climate. That's their biggest problem. But I think that'll fade away after a while.
Now, despite all the evidence that you have shown us, there is one more thing. The energy resources, in particularly the fossil fuel resources, are finite. Now, don't you think that policies are encouraging us to save with the knowledge that those resources are finite? So isn't there actually a silver lining? Don't you think that we should actually engage in being more reasonable in our consumption of oil, coal, etc.? Because even if there is no catastrophe, it will end someday.
I am not a particular fan of carbon as energy. It's just the best kind of energy because it's affordable right now. But whatever energy is available, whether it be nuclear or whatever, that would be fine as long as it's affordable and people can use it for a better life. Well, it turns out that carbon resources are only finite for a certain technology. But as we have found in the last 20 years, we create newer technologies that find more and more carbon. The United States is just fortunate to be the country that has more carbon than any other country in the world right now, until they find more in China or Russia or somewhere. So there's really, a tremendous amount of carbon left to burn. But, remember, we didn't leave the Stone Age because we ran out of rocks. We left the Stone Age because we invented something better. And we will leave carbon because we will invent something better, a better nuclear or some type of energy system. But I don't think we will run out of carbon. There's so much of it.
Je voudrais, s'il vous plaît, Loïc Le Floch-Prigent.
Loïc Le Floch-Prigent. I would like to add, to comment on what Professor Christy has said. Former French president said publicly in front of the United Nations that we had reached the end of oil and that we needed to prepare ourselves for something else. I raised my voice at the time saying we have resources that will allow us to burn coal for another 400 years and still very significant amount of oil to be extracted and burned. So I think that really there's no rush. But as you said, Professor Christy, economics are going to be the determinant factor. If the price of energy is right, we're going to stay with the same sources of energy. If we find less expensive source of energy, they're going to be the winner. It is an economic matter, and it has little to do with all the hysterics that we are witness from our political leadership, etc. Just a comment I wanted to make. Thank you.